So I heard we're going to be doing a little bit of math review and we're looking at function families. So I'm going to focus on the first two questions that you had on your worksheet and we're going to kind of talk through them and what this means for how it changes from the original parent function. Okay, so when we're talking about a parent function, it's if you were to take away all of the extra numbers in this function, what would it look like? So you can kind of see here, if I scribble out some of the numbers, the only thing we have left is the x on the inside of those absolute value bars. So this is my parent function, okay? And we're going to talk about how these extra numbers that we include in there change how that graph is shaped. So is it going to be more narrow, or is it going to be stretched and have it be wider and more towards the x-axis? Okay, these two numbers here are going to affect where that graph is placed on your coordinate plane. Okay, so the first thing I want to do is I'm actually going to pull up what the parent function is. So you can see here I have only this first equation checked to display. So this is your regular parent function. Okay, and you can see right in the center that has the vertex of 0, 0. So if I were to go back to this parent function here, if you were to try to incorporate some of the numbers in it to see why it's 0, 0, this is really the same thing as x plus 0 plus 0. Now, when you look at the absolute value equation, basic form, it looks like this. So you have the letter A out here. This number is going to change how it's shaped. Okay? You have x minus h inside the absolute value bars plus k. Now from here, the vertex is going to be h comma k. So you're getting your numbers for where that initial point is, how it changes horizontally and how it changes vertically. You're going to get those numbers from inside your absolute value bars and outside. Okay? The number that you have on the inside here, this is going to tell you how your graph is going to shift left or right. And this number on the outside is going to tell you how your graph shifts up or down. Okay. Now, depending on the numbers and the signs, it's going to tell you which direction out of the two that it's going. Okay. So you can see when we look back at our parent function here, it's not shifting left or right at all or up or down. It's starting directly at the origin. Now, if I add numbers on the outside here, so let's say I say plus 1, you can see how that graph changed. From having it be nothing, it shifted up 1. If I make it plus 2, it goes up again. So the number on the outside, if it's positive, that means that graph is going to shift up. So when I look back at our original function here, take away some of our extra stuff here. When I take a look at our function here, I see a plus 1 here. That means my graph is going to be shifting up 1 from that original parent function. Okay. Now let's meddle with some of the numbers on the inside. All right, so let's take that back to the original one. If I go in here, I'm going to do plus 1. Alrighty, I can see that it shifted to the left this time. Plus 2, still going to the left. So it looks like the bigger the numbers get on the inside, the more to the left it goes. Now what happens if that's a negative? All right, well, I see now it's going to the right. So it looks like negative numbers shift my graph to the right, and positive numbers shift that graph to the left. So if I see a positive number in here, that means that that graph is going to be shifting to the left a total of 9. Okay? So what I'm going to do is I'm going to go into Desmos and I'm going to take out this little part here. And I'm going to click it on. All right, so you can see here that it shifted up 1 and then to the left 9. So that's what those few extra numbers do. Now, the graph that we have that we want you to be looking at has some extra stuff happening with the x. So you have that coefficient. Now I pulled up something that I think is going to be a little bit helpful. So here, this is saying, what do numbers attached to the x do to your graph? Okay. Here, this is changing your shape. So notice there's no numbers added or subtracted in here. That vertex is still staying right in the middle at 0, 0. But the numbers in the front of x, those coefficients, are going to change how it's shaped. Now, as the coefficient gets larger, the width becomes thinner, so it gets closer to your y-axis, okay, closer to that line of symmetry. As the coefficient gets smaller, so if you're seeing more of a fraction or a decimal in there, it's going to stretch. So it's going to get closer to your x-axis instead. And if you note here, if there's a negative or a positive, it doesn't matter. We're simply looking at just the actual digits, how that's affecting your graph. Okay, so if we look back here, I'm actually going to pull up Desmos again. I think this is helpful to see. So if I were to take this out, okay, let's say I put a 2. You can see how the graph changed. It was a little bit wider. Now it's skinnier. If I change it to a 3, skinnier still. 4, 5, 6, 7, 8. You can see it's starting to get thinner. Now we had a fraction. So let's start with, maybe we'll do 5 out of 5, okay, because that's what we had here. If I change that numerator to a 4, maybe to a 3, to a 2, you can start to see here how it's definitely getting wider than that original function. Okay, so we're seeing that it's stretching. Now the negative sign here, if I go back and I put this out here, we had a negative. There's the 3, but if we put the negative sign in the front, it now switched directions. Okay, so if I look back here, the 3/5, okay, that 3/5, that's going to stretch our graph, and it's making it wider. Okay, the negative sign, okay, is going to have it reflect over your y-axis. So this negative sign here reflect over y-axis. Okay, so and you kind of saw how it changed when I pulled this up here. Okay, the negative sign in the front made it go over to the right. If I take that negative sign out, it's in the same place, just on the left side. Okay, so that's what we mean by reflecting. If you were to look at your y-axis being like that mirror, you're seeing, if you were to fold the paper over on itself, that's going to be in the same spot. Okay, so that's what we're looking at here. Those all different things that you're seeing with this function. Okay, taking a little jump, we'll look at number 2. Now, right away, I want you to notice the degree you have here, this exponent. Okay, same kind of idea. If you were to remove all of the numbers that you see, and we're just looking at the variables, what is that parent function going to be? So what's left over is I see y equals x to the 3rd. So when you're looking at your parent function, we are looking at a cubic. Okay, so that's what we're starting with, and then we're going to look at the changes. So this is, let me take that out of there. This is what our original parent function looks like, x to the 3rd. So you can see it starts down here, kind of hangs out in the middle, and then it goes back up. All right. I want you to continue thinking about what we said for question 1. Same kind of idea. Now these are, yes, dealing with absolute value bars, but anytime you're dealing with changing how a function looks, it's the same kind of idea, whether you have absolute value bars or if you have, and I put this to some number up here, okay, you're seeing that type of shift happen. So let's just kind of take a look at some of the basic numbers that we have here in question 2, right? Take some of the stuff away here. First off, this is making it look more complicated than it actually is. Okay, used to have that 2 out in front. Now the square root of 3 squared, this little relationship here is special because the squared, that exponent, and the square root cancel each other out. So really all you're looking at is 2 times 3, which we know is equal to 6. So what I'm going to do is make this look a little less scary. And I'm going to go and actually just click into this equation editor. I'm going to take that out and put the 6 in there. Okay, so we're not having it look as bad. So let's think back to what we did in the last question, all right? That number that we have added or subtracted on the end, that is going to have it shift up or down. Now it's positive, which means it's going to shift up 6, okay? We're going to look now at the number on the inside here. This is going to shift it left or right. And we said before, when we had a positive number, we saw that it was shifting to the left. That means when we have a negative number, it's going to shift to the right. I'm going to write out the word right. And that's 3/8. Okay, so right there, those two numbers, that's just changing its location on the graph. It's not changing the shape that we had here. So if I go and take out this fun thing here in the beginning, okay, and I click that on, okay, you're going to see, right, the shape does not change, just the placement, okay? So that's only the thing we're seeing here. Now, when we put that stuff in the front, we're seeing a whole different type of change happen with your graph, okay? So let's talk about what we're seeing happen here. Okay? We saw that that graph is changing direction, okay? Now, that direction, if I were to take out the negative sign here, let's see what that does. Okay, so the negative sign in the front is making it reflect over the y-axis. Remember, think about folding the piece of paper. So if you were to fold everything over here, that's a piece of paper, and you're folding it over to the other side, that's where you're seeing it reflect, okay? So the negative sign here, that's the reflecting part. That's over your y-axis, all right? What is the 14/5 doing? So let's take a look at that piece too, okay? So I'm going to cut that out. Alrighty, I can see my graph looks like it changed a little bit. Now, taking out that fraction, it looked like it stretched it a little bit. Now it looks thinner. The same kind of concept that we talked about here. The larger that coefficient is, now it could be inside the absolute value bars or outside, the larger that number, the thinner our graph is going to get, the closer to your x-axis it's going to be, okay? When we take a look at it here, we can see this number, 14/5, that is larger than 1. So it's getting larger than it was before, meaning we're getting that stretch, okay, where it's shrinking, all right? And it's getting more steep and closer to your y-axis. So that's what we can say then for this part. I'm running out of space here. So the 14/5, okay, it's making it go closer to your y-axis. Okay. And some people call that a vertical stretch because it's getting closer vertically to your y-axis. Okay, so that's what you might see on your answer key. Those are questions 1 and 2.